Alright, so a lot of progress on the chess game. Right now, we don't really have pieces, but we do have kind of placeholder units there. Um, yeah, we'll just get into it. So I can rotate the board. I can move the position of the light. It's kind of just rotating about a point in the middle of the area there. And then I've got the the rotation of the board is a separate control. That's the arrow keys, and so you can see all the SDL events. This is the movement of the mouse creates a huge number of events in rapid succession. Clicks. You can get the X and Y coordinate and the time it happened, when it happened, when you released it, um, and if you type um, the same information is recorded there. So here I hit F unintentionally, but I do have that set up so that we can do full screen. Now, the way selection is going to work, I need to be able to click on the piece, right? So I've worked out a scheme where, in addition to the square being colored with the selection color, so too is the piece in the square. So when you're in this selection mode and you go to click on a piece, you're going to click on something that's the correct color as far as the selection is concerned. So this is the 3D chessboard, and this is the yeah. So you can see a little bit of the lighting and stuff. It might be something to make more intense at some point, but for right now, I think it's pretty suitable. You can play with colors and things as we move forward with things, but I think as a basic starting point, this is really solid. Yeah. So we're working on the chess logic. That's going to be a state-based design now, where you select a piece, then you move a piece, and then your turn's over. So I really like how slick this is, popping back and forth. I just discarded that skirt, and honestly, now that I look at it, it looks like the board has a shadow. I didn't really intend it to be that way, but like it actually worked out pretty damn good. So we'll have to look and see, what we want to do with that. But yeah, so we've got the selection working. This eventually will not be displayed to the user. This is something that's like gonna happen in the background. I'm gonna take one of the click events, right? So when I get whatever event that says you gotta click at XY, um, at that location, I'm gonna read the pixel. I haven't looked at what SDL's setup for reading pixels is. It may actually be the same thing as, because as I recall, that's not actually part of GLET. That's part of OpenGL, because you're interacting with a frame buffer. So anyway, I just have to figure out what the read pixels command is again, and when I have that, I can take the pixel at the click and read it out, and then I can make a decision based on the shade that's there. I have the X in the red and the Y in the green. I then know what square was placed, and then we have the whole logic for the is equal and everything or not is equal, is legal. So then it's making sure that what you selected as your move is a valid move. Otherwise, you're going to be prompted to pick a different move because that was not a valid move. So we'll figure out what that looks like. But right now we have display. We have 95% of that selection scheme. I just have to figure out the reading out the pixels, and then we'll make the decision based on the read out color. Yeah, so cool stuff. There's a little bit of depth coloring also in the shader here, and I think it adds something to it. These are just placeholders as far as the pieces. I'm just adding them in there. They're just all pawns. This is the pawn model placeholder geometry. I actually just found out this morning that there's an OBJ loader that makes loading things you make in Blender like completely trivial. So honestly, things might get a lot cooler here really, really quickly because Blender is good software. They have all sorts of tools for laying out geometry, and if I can export it to an intermediate format that is, you know, OBJ is what this library supports, that has per vertex normals, UV mapping, per vertex colors. I mean, it's really nuts. And it's completely trivial to use. I looked at the example code. Seriously, less than a page printed. That they that there was any kind of like there wasn't really any kind of setup or anything. It was very minimal kind of setup and use. Actually, I still have it up. I can yeah. So that's how it goes. Basically, it's got whatever format here, to where it's like a whole bunch of triangles, and then each or points. I'm not exactly sure. We gotta look through the specifics, but basically it just gives you this really good information, or this good interface for pulling off the like the per vertex UVs. You know, that's as much as the scroll back on this thing allows for, but yeah, so you can load like up to 10 million triangle models is what they were saying. So it's really it's something else there. I saw that NVIDIA had a data set that was a tiling city, and I thought that might be cool to mess with. And certainly when I mess with the real GPU, I'll have all kinds of space to load that kind of geometry. They said it was about 9 million vertices, and realistically, you could just render that straight up. I don't know how they organize it with like multiple actual textures. Yeah, they call out specific image files. But it's just going to be a process of figuring out what this means. It looks just totally trivial to use though, in terms of loading geometry in a way where I can just kind of load it into my here I've got vectors for points, normals, colors, and this selection colors is to show off the this is the selection color, and so it's basically just to make sure that that we have a way of distinguishing every square from each other. Yeah. And I'm not doing any of the lighting because that would screw up my ability to pick those colors consistently.